Hey Algebra, today we are going to be working on lesson 5.8, which is graphing absolute value functions. Okay, so these ones are kind of cool. When you look at them, they're kind of fun. So we're just gonna work on them and we'll get right to it. All right. So the main thing for absolute value functions that you're gonna notice is that they have like a V-shaped graph, as you can see down here in problem 1. And then, yeah, we'll look at that here in a minute. One definition I do want you to know is a translation. So a translation is a shift of a graph either horizontally or vertically or both. All right, so I would make sure you either have that written down or know it. What a translation is. Okay, it's kind of like a slide if you slide the graph one way or another. Okay. So we'll look at problem 1. All right. Problem 1 asks, how are these two graphs related? We have the absolute value, y equals the absolute value of x, and y equals the absolute value of x, and then minus 2. Okay. You'll notice that the graphs have the same shape. And then it says each point on y equals the absolute value of x minus 2 is 2 units lower than the corresponding points on y equals the absolute value of x. Okay, so it's translated down 2 units, basically. The one on the right is. All right. And then I'm not going to make you do got it problem 1a. It's pretty similar to what we just looked at. It's pretty simple, right? I'm sure you can all tell that the graph here is translated up by 4 points, right? Because we are at, forgot I was using a highlighter. We're at 4 for the y-axis instead of 0, okay? So if we move on, okay, we're going to go ahead and, so problem 2 is the same exact sort of problem, right? We have the graph of y equals the absolute value of x plus 2, okay? That plus 2 translates each point on the graph up 2 points, okay? So that red one is the new graph there, okay? And yeah, that's really all that does, okay? The other part of this, if we look at these two graphs, we have the 2 now is inside of the absolute value symbols, okay? You'll notice that when we do that, now it changes by going left or right instead of up or down. All right, so I'm going to write that over here, kind of what to expect from these. Okay, so yeah, go ahead and write this down as well. All right, so I made these little, I mean, they're not really graphic organizers, but here, I'll make them a box. Okay, so we've got 2 boxes here for our 2 different relationships that we have. Okay, so whenever we add and subtract outside of the absolute value sign, so an example of this would be like y equals the absolute value of x minus 3, or y equals the absolute value of x plus 1. Okay, addition will move the graph up, and subtraction will move the graph down. Okay, so addition moves us up, subtraction moves us down. Okay, then if we have addition and subtraction inside the absolute value, addition is going to move the graph left, while subtraction will move the graph right. Now you'll notice that seems like it's a little bit backwards, so just be really careful when you do these, because typically when we think of graphs, we think negative is left, positive is right, when we're looking at the x value. Okay, so just be really careful because this is actually the opposite. So Examples would be if we have y equals x minus 4 or y equals x plus 2. All right. X minus 4, subtraction is going to move us right, and addition will move us left. Okay. So just be really careful, especially on those where the number is being added or subtracted inside the absolute value. Okay, that's an easy one to mess up. So once you've got this written down, pause the video if you need to in order to write it down. But once you do have it written down, we'll go ahead and move on to the next bit. All right, so problem 3 asks what is the graph of y equals x, the absolute value of x plus 5. Obviously, they already did that for us. So there's the example, right? The black one is the original with just absolute value of x, and then the red one is after we have added the 5 inside the absolute value, and it slides it to the left each point 5 places, okay? I do want you to go ahead and try to graph got it problem number 3 here on your own, so give that one a try. All right, and then we're also going to look really quickly after you've finished got it problem 3 at the definition of a piecewise function, okay? Absolute values are piecewise functions, okay? And that is because a piecewise function is a function that has different rules for different parts of its domain. Okay, I think the way that they put it is pretty good. So for example, when x is greater than or equal to 0, the absolute value of x is going to be equal to x. However, when x is less than 0, the absolute value of x is going to be equal to negative x. Okay, so you can see there, the split point there is 0. And you've got two different rules for positive numbers versus negative numbers. All right. Another example of a piecewise function, and I'm just kind of reading this, is a step function. Okay, a step function, this is what they have in this graph right here. It's going to pair every number in an interval with a single value. Okay. And like it says, it looks kind of like steps to a staircase. So you can kind of see that with the red points and everything. Just a reminder from when we graphed on number lines, filled in circles means it's equal to there. Open circles means it's not equal to there. All right. So when y is 0, or sorry, when, yep, that's what I meant. When y is 0, nope, that's not what I meant. Sorry. When x is 0, y is equal to 0, whereas leading up to it, but not at 0, y is equal to negative 1. Okay, that's kind of just what we looked at when we did graphing on the number line. Okay, open circle is not equal to, closed circle is equal to. Okay, so just a little bit of review thrown in there for us. Okay. Here's an example of that. All right, in got it problem 4. So it says a school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. Make a graph that models the relationship between the number of students x that go to the game by bus and the number of buses y that are needed. Okay. So it says you will need 0 buses for 0 students. All right. So you can see that with this point right here, 0, 0. All right, and you can also see that up here because any more than 0, you're going to have a bus. You're going to have one bus at least. Okay, so that's why that is an open circle there. All right, and then up to 60 buses, you're going to have one bus. And then everything greater than 60 buses will have 2 buses. Okay, you'll notice that that is when x is greater than 60. or number of students is x, by the way. When x is greater than 60, we need 2 buses. Okay, which is why there's an open circle, because this right here does not have the equals sign on it. All right, when s is less than or equal to 60, we're going to have 1 bus. All right, and because it has this equal to sign, okay, that's where we're going to have a closed circle again. Again, just more review for us on this. But these graphs work the same way those number line graphs did in the past. All right. So yeah, that's pretty much it for that. I do want you to try out Got It Problem 4 for me really quick. And then once you have finished that, we are going to be done with this video lesson. So yeah, hopefully it went well. Hopefully you got good notes out of it. Let me know if you have any questions, and then I will see you guys in class.